Okay, we were talking about the grape juice, the red grape juice in these stainless steel vats in the Tuscany region of Italy. Yes? Okay, really we were just talking about this differential problem. So I rewrote this stuff up here. That way we have this information. You have this information in front of you. We had filled out this chart, and when we filled out this chart, if you recall, we used the equation dy dt equals, it was 2 times the square root of y, yes? Yes. That was the equation that we developed the pieces above. Okay. We were ready for F. Now we gotta get our brains back into this situation here. Suppose there were 4 inches of grape juice initially. In order to estimate the depth after 1 hour, we will assume that the rate remains constant for the first hour. How did we arrive at an answer of 8 inches and then use this technique to complete the chart? Okay? So that is the situation we have. So if you recall the whole grape juice / water question yesterday, it's hard to start this problem if you don't have an initial amount. Where are we starting? So here, they have told us 4 inches. So at time 0, we start with an estimated depth of 4 inches of grape juice. Okay. Now, after 1 hour, it says we assume the rate remains constant for the first hour. So if it's remaining constant for the first hour, what are we talking about here? And if I recall, weren't we given? Yeah. If you go back up to, and I had that my aha moment, which didn't make sense to you guys yesterday, but we were given right here a rate of 4 inches, yes? Okay. And so, with that in mind, if your initial depth is 8 hours, okay, and then in that first hour, it's a constant rate still, so increasing 4 inches, that puts us at 4 plus 4, which is 8. Are you guys seeing that? Because it's this initial 4 with the fact that it was then, our rate was 4 inches per hour. Okay, now it says assume that it remains constant for the first hour. With that in mind now, okay, how do I want to do this? Actually, wait a minute. I need to take you a different place, actually. Sorry. Right here, estimated depth of grape juice was 4 inches, yes? Go up to this chart here. What do we know? This is where I need to connect, sorry. When the depth is 4 inches, what is the rate the depth is changing at? 4 inches per hour. So this plus 4 down here is the fact that when my depth is 4 inches, the rate is changing at 4 inches. So this 4 here plus this 4 here. That's the connection I need to make, sorry. Does that connection make sense? Because we're going to reuse that connection then. Because now, after 1 hour, what is our estimated depth of grape juice? And it is 8 inches, yes? Okay, go back to our other chart. Do we have a depth of 8 listed here? No, but do we have something fairly close to 8? And this is it's all just kind of an estimation here. 9 is not 8, but it's close to 8, yes? When the depth is around 9 inches, what is the rate increasing at? 6 inches per hour. So what am I going to do here? When the depth is here at 8 inches, which is close to 9, we're going to take that 8 and we're going to add, what is my rate changing at now? 6. And 8 plus 6 is 14. So now I have a depth of 14. Do we have a depth of 14 up in our chart? No, but it's really close to 16. what is the rate changing at when the depth is close to 16? It's increasing 8 inches per hour. So what do I do with my 14 down here? You add 8, and 14 plus 8 is 22. Are you following what I'm doing? Because we just keep doing this the whole time. Now we have a depth of 22. Thank you. And with a depth of 22, 22 is close to 25. What is the rate changing at 25? 10. So now we're going to do 22 plus 10, which is 32. You know where I'm going with this, right? We don't have a depth of 32, but 32 is close-ish to 36. At 36, the depth is increasing at 12 inches per hour, so 32 plus 12 is 44. And it's getting farther off, but it's still good enough. At 44 inches, which is close-ish to 49 inches, my depth is increasing 14 inches per an hour. So 44 plus 14 is 58. Okay. Do notice, and I didn't really point it out here, but the directions did say to estimate. Okay. This is not a precise thing, but it did say to estimate. Now, I guess in my notes, I wrote down in here at d equals 4 inches, the rate is increasing 4 inches per hour, so 4 plus 4 equals 8. But that's kind of what we talked about. I saw several of you guys writing stuff down. Did you write some notes to help you there? Now, you're going to have to flip back and forth. Just FYI. Okay, so down at G, how many functions would satisfy your differential equation? So the idea, and of course the notes from yesterday erased, but we were talking about these differential equations and we tag a plus c on them, right? If it's a differential equation is x squared plus c. How many different options are there for that equation? Is there a set number? So if you have a differential equation and we go and solve it, then we tag on that plus c, right? And the question is, how many functions would satisfy your differential equation? When you tag on that plus c, that's one general equation, but how many particular options are there? And that would be just an unlimited amount, or in other words, infinite. So I just have an infinity sign in there. How many functions to satisfy your differential equation? It's not a set number. Okay. What information determines which particular solution you find? Basically, in other words, how are you going to find your C value? Okay. Or in the one we just did, in this case, it was how are we going to find a K value? Well, in order to find that K value, we had to know what it started off as, right? Or we had to know some kind of information here about what it starts off as. Or when we talk down here, we have to get to specifically, eventually you have to have an initial amount. Okay, if you don't know where this level starts at, we can't go from anywhere. Okay, so obviously several things you have to be provided, and I guess ultimately though, you can't find your plus C or your K value, you can't find that stuff without your initial amount. And how is this worded? What information determines which particular solution you find? And so that would, I guess, which particular solution you find would be your initial amount. Okay. I'm going to introduce the idea of something called a slope field, which is what this is here, okay? But they're going to ask us to graph this, use the data from the second table, and plot this particular solution of the differential equation. It says using a blue colored pencil on the grid below. And then we're going to plot another one using green. If you want pencils, I have them, or crayons even. I'm not sure how well crayons will do on this, but, you know, to each their own. Some of you guys prefer your colored pens. Some of you prefer your colored pencils. I don't care. It's your notes, not mine, right?
I might know.
Okay. So, we are using, let me get a better blue. We're using the data from part F and plotting that particular solution in blue. So if we go back to part F, at time 0, the estimated depth is 4. So 0, 4. Now, notice it counts by tens. Those little random marks, we'll talk about those once we get some of this plotted, okay? Because this is a slope field in the background. Just take out what it is right now. I'll explain it more once we graph. Okay, so if I'm doing 0, 4, then just realize, guesstimate between 0 and 10 as to where your 0, 4 is. Does that make sense? Okay. 1, 8. They don't have to necessarily land anywhere in relation to those pieces, okay? 2, 14. 3, 22. 4, 32. 5, 44. 6, 58. Sorry, we didn't get through the halfway through point. But in all reality, we are going to be done by the halfway through point because we talked so much in the beginning. So, okay, did you get something that looks something like this? Okay, so, excuse me. If I attempt to connect those dots, I missed my last dot. Dang it. Okay, I can't do this on the BenQ. We're just going to pretend that I hit all my pieces there, right? Okay, this is one particular solution, right? And this was based on the fact that the initial amount was 4, which was given to us in part F, right? Now, first of all, the idea of the slope field, and we will, I assume at some point, practice drawing slope fields. And in fact, our next lesson is all about slope fields. So probably going to talk a lot about them then. But the idea of the slope field is all of those little marks, they're not all at the same angle if you notice, right? Especially down here. But they all represent the slope at that particular point in the graph. Okay, so if you notice, and it's not going to be precise, but does my curve kind of follow those slopes? Okay, because of based on the points. And that's the idea of a slope field. As I said, slight introduction to our Monday lesson. Well, we've got more to come, so take your dizziness medicine before Monday then, I guess. Now, H says to plot another function that also represents a particular solution of the differential equation. Basically, if we changed our initial amount, okay, here our initial amount was 4. Well, I mean, we can pick anything we want. I'm going to use what I have in my notes, which, what if my initial amount instead was 10? Well, what's that going to change each of these dots by? 10. You're just going to, they're each going to be 6 higher, yes? And so this is going to represent another particular solution is what the idea is. Now, can you tell 6 higher? Do you need to, that first dot was 1, 8. So 6 higher than that is going to be 14. At 2, it was 2, 14. So add 6 and I'm at 20. At 3, it was 22. So what, 28? At 4, it was 32. So 38. At 5, it was 44. So 50. At 6, it was 58. So 64. You see the same curve happening. That's not exactly great, but that's all right. Oops. So the idea with the slope fields here, you know, if you look, if we've done this properly, my curve has the same angle as the slope pieces. Because what those are just small little pieces of slope at that point. Now, I think, man, I did that wrong. Because I just answered I for you guys. Forgot what I was. So I answered it as opposed to asking you guys. Dang it. Do you notice a relationship between your graphed solutions and the slope field in the background? Dang it. It was a good discussion question, too, and I kind of asked it, but I more told you guys. Oh, well. So, yeah. Those slope field little pieces are small little, like, I guess I should say tangent lines, right? They're tangent to the curve, you know, at those points. They are the rates of how fast the depth of the grape juice is changing at a specific time. And since the rate is not always the same, that's why my slope is different at different points, right? My curve doesn't always have the same slope. I mean, what do we have? A square root curve, which would be a squared curve in this scenario then. Okay. So, let's see. Some information I have is that slope fields look like small tangent lines. You can take what you want out of this at certain x values, or some x values. These are the rates of how fast the depth is changing at a specific time. Okay. That's what I got. Yay.